Hello everybody. In this video we're going to take a look at some review problems regarding trig functions. If you have a unit circle, I would recommend using that as reference. This is my unit circle I will be referencing for this video here. Right? So in this first problem here is asking us to convert the angle measures from either degree to radians or radians to degree. Something we should remember is that based on a unit circle, 180 degrees is equivalent essentially to pi radians, right? By extension, 360 degrees is also equal to 2 pi. So essentially, one full circle has a circumference, a unit circle specifically, has a circumference of 2 pi. By the same time, it also rotates an entire 360 degrees. So that's how these two actually relate to each other. So when I'm converting something from degrees to radians, I just have to essentially multiply it by some conversion factor. So to get from degrees to radians, what we need to do is multiply the degrees by this factor here, which is pi divided by 180 degrees. Okay, so if our example here has 170 degrees, well, what we need to do is take 170 degrees, multiply it by pi over 180 degrees, and then now we'll be able to simplify it. This gives us 170 degrees pi over 180 degrees pi. And there's a few giant ones here. Our units, this degree unit disappears, pi becomes a giant 1. I can simplify 170 divided by 180 by dividing each of them by 10, thus giving me 17. There's actually no pi here. It should be 17 pi over 18. So this right here is equivalent to 170 degrees, right? For C, we do the opposite. Instead of going from degrees to radians, we're going from radians to degrees. So in this particular case, we'd have to multiply radians by this factor of 180 divided by pi. So here I'm given pi over 15 in radians, and I want to multiply it by this right here, 180 divided by pi. It should be 180 degrees here. Okay. So now this gives me 180 degrees pi divided by 15 pi. So right over here we have 2 pi's. They become a giant 1. And 180 divided by 15 gives us 12 degrees. So pi over 15 radians is equivalent to 12 degrees. So if you reference your unit circle, they'll be in the same exact area of the unit circle. So that's converting radians to degrees or degrees to radians. The next one here is determining the reference angle for these particular angles. So some things we need to remember is that reference angles are in quadrant 1 of unit circle. And what I mean by quartile 1 here, it's going to be, if you reference your unit circle, this portion, this upper right hand corner, is quadrant 1. As you can see, the degree measures vary from 0 all the way up to pi over 2, or from 0 degrees to 90 degrees. Okay, so when things are in quadrant 1, your angle is in between 90 degrees and 0 degrees. Okay, and when it comes to Q2, as you can see, it's between 90 and 180. Quadrant 3 is between 180 and 270, and quadrant 4 is between 270 and this, like I said, one full rotation even though it says 0 degrees here, you can also say that this is 360 degrees. Okay, so 0 degrees and 360 degrees will give you the same exact values because they're in the same exact spot in the unit circle. So in this case here, I have 141 degrees. So that right here, that's going to be in quadrant 2 because 141 degrees is in between 180 and 90 degrees. But how do I determine the reference angle? So if you look back here again, as you can see here, let's take a look at 30 degrees. This right here has a reference angle. I'll call it theta subscript r is 30 degrees. And this, and you see these are the coordinates for that. There's actually going to be 3 more spots in this unit circle that have similar coordinates. It's just the signs are going to be a little bit different. But as you can see here, take a look at this guy. This one is 30 degrees away from 180 degrees. As you can see, they have similar values. It's just that the x value here is actually going to be negative. So the reference angle for 150 degrees is actually 30 degrees. And how we get the reference angle is we essentially subtracted 180 from 150. And the same can be said for this angle here, 210. This is also 30 degrees away from 180. And as you can see, it has the similar values here. It's just there's now they're negative in both coordinates. And over here as well, this also has a reference angle of 30 degrees. And it's 30 degrees away from 330, or it's 30 degrees away from 360. As you can see, the same exact coordinates again. So in this case, this is the conversion we should use. If in Q1, that's going to be our reference angle. In Q2, how the angles in Q2 relate to that is it's 180 degrees minus our reference angle. In Q3, it's going to be 180 plus our reference angle. And in Q4, it's going to be 360 minus our reference angle. So in this particular case, knowing that 141 is in Q2, I would do this. So I have 141 degrees is equal to 180 degrees minus our reference angle. So here I don't know what my reference angle is. By using this equation, I can determine what it is. And if we were to do our quick little algebra here, our reference angle will essentially just be 39 degrees. Right? So setting this one up, it's similar. In this case, this is actually going to be in quadrant 3 because 227 is in between 270 and 180 degrees. So we want to use this guy. So Q3, 227 degrees is equal to 180 plus our reference angle. And then we would just have to solve for reference angle there. So now, this one right here, we were asked to find the exact value of these functions given our particular angles. So this is where it's good to have your unit circle handy. Right? So here, the first problem asks us sine 45 degrees. So first we need to figure out where is 45 degrees. So 45 degrees is actually going to be in quadrant 1, right over here. And some things to remember is the coordinates at this particular angle that are on the circumference of our circle here, this is going to be the coordinates of our trig function at 45 degrees. And as you can see right down here, right, all of these coordinates are equivalent to the cosine and sine of the particular angle. So in this case, given that this is 45 degrees, you can say that this is equivalent to cosine of 45 degrees, comma, sine of 45 degrees. So the thing here is, so if I'm trying to figure out sine 45, all you need to look for is the value at the y coordinate. So the exact solution to this problem here is essentially using the unit circle. Sine 45 degrees is essentially going to be root 2 over 2. So root 2 divided by 2. Okay. So tangent here is a little different because it's not just one part. I mean, it is a one particular value, but it's not directly stated in the unit circle. You might have to do a little bit more calculations because the relationship between tangent, sine, and cosine is that tangent of a given angle is actually going to be the sine of that given angle divided by cosine. Right? So essentially to figure this value out is first to determine where is 4 pi over 3, where is 4 pi over 3, what is sine, what is cosine, and just do the calculations. We would have to do sine of 4 pi over 3 divided by cosine 4 pi over 3, right? And then we'd have to simplify that further. And of course, cosine essentially is just the x coordinate. And the last problem here, specifically, something we need to take note is that there's a specific interval that we need to account for. So if our angle is in between 0 and 2 pi, essentially, I am only looking at the values within one full rotation of our unit circle, nothing else. So for us to find theta, there's actually multiple ways we can do it. But the first step is always to isolate sine theta. So in this case, we have sine theta is equal to -1 over 2. Right? Because all I did was divide 2 to both sides. Therefore, sine theta should be equal to -1/2. So if you're to use a calculator, one of the things that to find the angle, one thing you can do is take the inverse of the sine. So what the inverse does, remember, is it swaps the inputs and outputs. So if you put this in your calculator, you're going to get the angle of, let me see, I believe it would be -30 degrees. That's what you would get in your calculator. However, this is not in our interval. So it looks nice. It technically is correct, but it's actually not an interval. So what I'd recommend is reference your unit circle again. Okay. So sine, remember, is the y values of the coordinates. So you want to take a look at our unit circle and take a look for all the y values that are -1/2. Right? So considering the y value is negative, that must mean it has to be below the x-axis. So you should be looking in the third and fourth quadrant. And in this case, as you can see, right over here, we have a y value of -1/2. And right across from it, we also have a y value of -1/2. And as you can see, the angle measures that actually give that here is 210 degrees, or 7 pi over 6, and 330 degrees, or 11 pi over 6. So those are going to be our two solutions, because if I do sine of 7 pi over 6, I will get -1/2. So the proper answer here, using your unit circle, should be 7 pi over 6, because look, it's in radians, so I should have my solution in radians, and it's also 11 pi over 6. So given our interval, those are going to be our solutions. Of course, this one here is going to be a little bit more difficult because you have to take into account, just as I mentioned before, tangent is sine theta over cosine theta, right? So here I have tan theta is equal to -1. So because it's 1, the things that you should be looking for is where is sine and cosine going to be the same exact number. But also you need to think about, because it's negative, one of these, sine or cosine, have to be negative. So in this particular problem, you will need to reference the unit circle to give you the exact angle measure that gives tangent theta equals -1. Okay. If you have any other questions, be sure to let me know. Go to Google Classroom, make any comments or suggestions, or email me through there. Alright? That's it for today. See you guys later.